Now, what we're going to do is we're going to build the engine to the car, the main components of this contract. If you want to take a break and be proud of yourself right here, go for it. If you want to even pause the video, start writing some of your own tests, write your own deploy scripts, go for it. But let's go ahead and start building this engine. And we're going to be building this a little bit different than some of the other projects. We might even be testing some of this along the way to make sure we get things right. So I'm going to go ahead, create a new file, DSCEngine.sol, decentralized stablecoin engine. And let's build this engine to this car. All right, let's go back to, I'm just going to copy paste this beginning part. Let's come to the engine, paste that in. We have SPDX, layout of contracts, pragma solidity, contract, DSCEngine, like this. And let's give this a lot of NAT spec. All right, title, DSCEngine. I don't want that. At author, Patrick Collins. The system is designed to be as minimal as possible and have the tokens maintain a $1 token equals $1 peg. I'm going to toggle the word wrap. This stable coin has the properties genus collateral, dollar pegged, algorithmically stable. It is similar to DAI if DAI had no governance, no fees, and was only backed by wrapped ETH and wrapped Bitcoin. At notice, this contract is the core of the DSC system. It handles all the logic for minting and redeeming DSC, as well as depositing and drawing collateral. At notice, this contract is very loosely based on DAI, on the MakerDAO DSS DAI system. You might be asking, Patrick, that's a lot of text here. Yes, we want a lot of text. When people read our code should be readable. Remember, your code is going to be written once, read hundreds of thousands of times. I have read the Aave and Maker code so many times, and so many other people have as well. You want your code to be very verbose so that other people can come and understand what's going on. So let's begin. So let's think about what are the main functions that our project should have. What are the main things that we should do, right? Before we even start coding anything. And oftentimes, a lot of people will take this step and will actually create an interface for their code. They'll create an interface and say, hey, here's all the functions that I want this to do. And then they'll say, hey, our contract is that interface so that they don't forget any of those functions. For us, I'm just going to go ahead and write them out here. So I want one function to be function deposit collateral and mint DSC. I want people to be able to deposit their DAI or their Bitcoin and mint our DSC token. I want people to redeem their collateral or DSC, right? When people are done with doing whatever they want with the stablecoin, they can turn the stablecoin, the DSC, decentralized stablecoin, back in for whatever collateral they originally used. I want people to be able to function burn their DSC. And the reason for this is if they're nervous that they have too much stablecoin and not enough collateral and they want just a quick way to have more collateral than DSC, they can quickly burn stuff, which is another part of the system. We should even put a point in here. Our DSC system should always be over collateralized. At no point should the value of all collateral be less than or equal to the value of all the DSC, or the dollar-backed value of all the DSC. We should always have more collateral than DSC in the system at all times, and we need to code in such a way. So burn DSC is a function that will make more sense in a little bit. We should have a function called liquidate. And this is going to be a really important function. The reason that we're always going to have more collateral, if the value of their collateral drops too much, let's say I put in $100 worth of ETH and I minted $50 worth of DSC. I have more collateral than DSC. That's good. What if the ETH price tanks to $40, 40 ETH? Now we are under collateralized, right? Now we have less ETH than we have DSC. And this user should get what's called liquidated. They shouldn't be allowed to hold a position in our system anymore. So ideally we set some threshold that's too low. Maybe it's 20%. And if you hold $60 worth of ETH and $50 worth of DSC, you should get kicked out of the system because you're way too close to being under collateralized. This liquidate function is going to be the function that other users can call to remove people's positions to save the protocol. And we'll talk about that a little bit more very soon. And we're going to want a function health factor. This should be an external view function, or excuse me, get health factor. And this will allow to see how healthy people are. So let's go back up to this example here. So if the price of ETH dumps to $40, we're now $10 under collateralized, right? And that's not good. That's really bad. We never want this to happen. So what we can do is we can set a threshold to, let's say, for this example, 50% or 150%. So if you have $50 in the system, you need to have at least 75 ETH at all times. This way, there's a little bit of a buffer. That way we can never be under collateralized if the price tanks here. If you go to $74, now what we can do is we can liquidate and we can say, hey, if someone pays back your minted DSC, they can have all your collateral for a discount. So maybe we say, hey, somebody pay back this 50 DSC and you can have this $74 worth of ETH. Somebody's going to be very incentivized to do this because they're going to make $24. So we'll set some threshold, maybe 150%, and we'll say, hey, anybody who liquidates your position, if you're under the threshold, they can have, as a reward, some of your extra collateral. And this will incentivize people to always have extra collateral. Otherwise, they're going to lose way more money than they borrowed. If that didn't make sense. So one more time, let's do that example. So if I put down $100 worth of ETH as collateral and I mint $50 worth of DSC, now I'm going to go off and do whatever I want with DSC. Price of my ETH tanks to $75, or better yet, let's say $74. Some other user is going to see, oh my God, under collateralized. And we're going to let people liquidate their positions if they become under collateralized based off the threshold. Some other user is going to see that and they're going to say, okay, I'll pay back the $50 of DSC. I'll pay back the $50 of DSC. So now this person has zero debt, and in return, get all your collateral. So now this person has $0 worth of ETH, and this user got the $74. And all they had to do was pay $50 of DSC to get $74 of ETH. So this person is now up, just made $25 or $24 by liquidating you. They're incentivized to make money. And this is your punishment for letting your collateral get too low. So hopefully that makes sense. If this system of liquidations doesn't make sense to you, you know where to go. Come to the GitHub repo associated with this course and start joining the discussion. All right, so hopefully this made sense. If it doesn't, use the discussions tab, of course. Now these are kind of this combination function. We're probably going to want a function just called deposit, this, deposit collateral, external. We're probably going to want a function redeem collateral, external. And then we're probably going to want, along with a burn DSC, we're probably going to want a function mint DSC, external. And these look like these are probably going to be the majority of what a protocol does. And what a lot of people even do is sometimes they'll even write tests right now, describing what each one of these should actually do to the system, right? We're not going to do that, but we may actually write some tests as we go along here. And I like to write my deploy script kind of early, and you'll see me do that here. That way I can write tests using my deploy script. So let's go ahead though.